Hello, Professor. Today we would like to present our final project, which is the developing a web-based management system for hospital pharmacy inventory. So let's start from the project rationale. So in these projects, we aim to develop a digital hospital platform that can track and manage the pharmaceutical inventory by using modern technologies that aims to improving its prescription accuracy, enhancing data quality, reducing waste, and ensuring the drug availability. And for the problems of these projects, first, because pharmacies cannot collect drug inventory data in a short period of time, so it's difficult to evaluate the inventory and order drugs frequently. Second, because pharmacies face the challenges in collecting inventory data promptly due to manual process, and because they do with manual, so it can cause a time-consuming process, risk of errors, inefficiency, and the data inconsistency that the data file received may contain the incomplete data, duplicate entries, or inconsistent data formats. So our project goals, we aim to develop a web-based pharmacy inventory system to effectively manage and analyze large medication datasets for improved performance. So the first one is modernized hospital pharmaceutical inventory system to be able to accurately track drug stock and usage. Second is we use the time series forecasting profit to predict and determine remaining days for each drug. And the last one, we use the time series forecasting profit to recommend the drug purchase plan. And for the solutions, first we standardizing data and integrating automations to assist with calculations by using profit. Second is increased data accuracy by dual data cleaning. Third one is centralized data from multiple sources. And the last one is demand forecasting to predict the future needs and avoid the stock out and overstocking. And for the technology feasibility, we select tools that are reliable, scalable, and suitable for handling large-scale inventory data, which has the Apache Spark, Apache Airflow, and InvenTree, which is an open-source inventory management system to manage the pharmaceutical inventory data in our project. And engineering solutions, our solution is using an ETL pipeline, which the first is extract the data from multiple sources, then is the transform by standardizing and cleaning the data, and lastly is we'll load process data into a centralized database. And for data cleaning, we focus on error correction, just as punctuation issues, and we use the Apache Spark for distributes and parallel processing to automate cleaning tasks. And for our stakeholder, there are Chiang Mai municipalities, hospital, pharmacies, and patients. And the scope, first is the drug inventory monitoring, which helps to track current stock levels and identify the replenishment needs. Second is system integration with hospital database to synchronize operational data. Third is data analysis and forecasting to support the future stock planning. And the last one is the data cleaning and validation to ensure data accuracy. And for the constraints, so first, the system must handle large amount of the data from multiple sources, and the second is the data processing should be automated and updated daily. And next is the diagram system or operation. So I will briefly explain this. So we have the three different sources, which are from the hospital OS, hospital office, and the external hospital external source. So firstly is we'll retrieve data from three different sources in the form of Excel files, and then we're gonna use the PySpark for cleaning and ETL data, and use the inventory to view the drug inventory and manage the various data in the pharma analytical database that locate in our project developer local computer. And the other developed system are medication usage anomaly detection to analysis of abnormal drug usage based on data in inventory changes, and purchase order calculations to calculate for recommending the next drug purchase. And next is the file appearance. For the hospital OS, it is the patient medication dispensing history. Hospital office, which is the main pharmacy inventory chain history. And for price list drug catalog, which in the hospital external source is show the drug price from multiple company. And for pharmaceutical company preference list, which in the hospital external source is show rank list of drug price by company for purchasing priority. And because some files input it in the form of PDF file, but in our project it needs to use the data that in the table format, so we convert from PDF file to an Excel or CSV file.
Next is file upload system. First, when we enter the website, we will see the login page. If this is first time using the system, you need to sign up or log in with Google. For demonstrate, I will log in with the Google. And after logging in, we will be redirected to the upload page. Next, I will upload a file in example. And first, you can click on select category and choose them. For example, I will choose hospital OS. And after that, we can select the file that we want to upload. Next, click on upload and analyze button. This will send the file upload to the backend system to check whether the upload file met the required column for hospital or OS category. And after analyze is complete, the backend will return the result. Next, let's take a look at the activity log. In this section, you can see the list of files that have been uploaded of the system. You can also click on detail to view more information, including which pharmacy uploaded file.
This is our problem and proposal system for our project. So first is data content excessive symbol. So the solution is view data cleaning for more convenient analytics. Next is disparate name. So in the both file, hospital and hospital office, they have drug in common as almost the same, but the name isn't right the same way. And next is the duplicate code. So in both files, we saw the pattern in the drug code that some are identical, some has the same code but different drug, and some has the same drug but different code. So what do we do? This is our old solution for this problem, which is called pharmacy matching, that divided to three steps. So first is the name identical the same, we use it. So next is if the name are different but code is the same, we use the code for mapping. And if none of it are connected, we use mapping table to connect both tables together that name IFIM code, as you can see in the both table. So next is you can join both files together by using the previous priority matching rules. This is our old solution, and this is our new solution. This is a new file format from pharmacies. they successfully export hospital office that contains the same drug code that can indicate as the same drug as a hospital is. So we directly join with the drug code. Next, how we find remaining stock and daily drug usage. First, how do we find remaining stock? First, we have a hospital office file, which is monthly stock moving data. So next is we add month and year and join them together to indicate time for each month for each drug. And next, we find the latest drug usage history for each drug to find the real recent stock for the drugs. So next is daily drug usage. These are hospital OS data with daily drug consumption historical data. And what we're going to do next is we aggregate daily drug usage. And after that, we're going to put this data into the profit. Profit is a time series focusing to decide that to predict that future value based on historical data. So we use this tool to forecast drug demand and pattern for the future need and optimize inventory level that help pharmacy decision making more than assumption. So this is our challenge for the profit on the accuracy. So we observe that the drug with higher daily usage tend to have higher forecast accuracy, while drug with low or irregular usage usually show low accuracies. For example, in the left table show that the drug that has almost everyday use, and the right table show that the drug that has few use. The graph on the right illustrates this difference between high frequency and low frequency drug usage pattern. So we use profit forecast data to create medication usage predictions. So this table shows that each drug has total usage in X days that called lead time. So lead time is the time that we need to wait after order the drug and waiting for them to arrive in the hospital. So the next is how we calculate drug order for the pharmacies. So we use the rule that if the profit results at greater than the remaining stock from inventory, so we create purchase order. If the profit result is less than the remaining stock, we are not creating purchase orders. And we use the latest right rule to create a purchase order calculations in inventory. So each item include a required quantity, pack size, unit price, and total cost based on predicted drug usage. So the high demand drugs have higher order quantity, while low demand minimize to remove overstocks.
Next is an architecture diagram in InvenTree. To wrap up, this architecture diagram will show how all components work together within the inventory system. So our workflow is divided into two main API process, which the first one is the data migration for setting up the new drugs, and the second one is the sale order creation for tracking the daily drug usage. And then all inventory data will aggregate and export it into the CSV or bucket file for further analysis. And the key main part of our architecture is the integration of machine learning by using the Prophet model, which analyzes the historical usage data such as the daily usage of drug A, B, and C to forecast the future drug demand, and this will enable the system to recommend the procurement decisions and suggesting to the pharmacies like what exactly has to purchase. For example, buy drug B 500 units from company A. And here is the slide that shows the data migration and process of phase workflow. And here is the daily operations workflow, where the system is creates a sale order to record the actual drug usage. And here is the structure and the appearance of the hospital office file and the hospital OS or the daily usage file. So in the OS file or daily usage, as you can see, there is no information about the batch or lot number and also supplier, manufacturer, or expiry date. So this is the data quality issue in the original datasets that is from the hospital. Therefore, when importing the file into the system, I have assigned the default values, which the supplier and the manufacturer be unknown, and batch and expiry dates as the manual required or none, and the unit I state as the unspecified, so pharmacists can manually enter or collect the information later. And here is the execution of the data migration process, where the system reads the CSV file and it will sequentially import the drug records into the inventory database. And here is the execution of the daily operation process, that the system will read the daily usage file and it will automatically create the sale orders transaction to deduct the corresponding drug quantities from the inventory. And if the system encounters a drug that was not previously created during the migration stage, it will detect as a new drug and it will automatically create the part in the system, and then it will proceed to generate the corresponding sale orders transaction. And this is the purchase order workflow, that this workflow will describe how we manage the procurement process from analysis to purchasing. And before generating a purchase order, the system will first perform a low stock alert that we have changed from static setting to demand-driven threshold setting, where our minimum stock threshold is directly synced with the Prophet's 90-day forecast. And the system dynamically adjusts the minimum stock threshold based on the daily usage, which the high usage, it automatically raises the threshold for an early alert and ensuring we have enough time to restock. Conversely, for low usage item, it will delay ordering to keep our inventory lean and prevent the overstocking. And in this slide, it shows an example of drug D2611, which the left side is from the Prophet model, that the predict 90-day demand is 6,547.02 units, which we use as the minimum stock threshold. And on the right side in the inventory system, it will automatically launch it up to 6,548 to ensure the sufficient stock coverage. And here is the execution of automated procurement. And on the left, the system calculates the required quantity using the Prophet forecast. And on the right, it automatically generates purchasing order in inventory by grouping item by suppliers. So next, let's see the inventory demo. So this is the first page of the inventory after the user is logging in. So on the left tab, the system will provide a quick overview of the key inventory, just as the latest part, low stock item, purchase orders, and sell orders. And next, let's see the parts of the inventory. So here we can see the drug ID, drug name, category, and stock. And as you can see, it has like some stock that still doesn't have on order. And I will explain this later why it doesn't have why it's not create purchase order. And next is the stock of the inventory. So this page will show the stock that has been created in the system and the stock that has already been shipped to the customer. So we will show the drug ID, drug name, quantity, batch or lot number, the purchase price, stock value, that is the multiple the purchase price with the amount of the stock. And in the last column, it indicates the unit of measurement. So sales orders that are currently in a progress status, because the hospital office file is used for their migration, only contain the total stock for a certain month from the previous year, while the daily usage file records the actual daily drug usage. So the issue we encounter is that like some new drugs appear in the daily usage file, but it doesn't exist in the migration data. As a result, when new drug is created, it has an initial stock is equal 0, so inventory cannot ship the order or deduct the stock. And next, let's see the suppliers. Here is the suppliers of each drug and manufacturers. And the last one is the purchase order, which is based on the demand forecast from the profit model. And here is the appearance. So next, here is the explanation of why some drugs doesn't have a purchase order. So to generate a purchase order, the system requires the demand predictions from the profit forecasting model. For example, this drug doesn't appear in the profit dataset, so the system doesn't have the sufficient data to estimate its future demand. Therefore, no create the purchase order automatically. And additionally, I didn't do a hard code default order quantity just as 500 units because this could lead to the overstocking. And here is to verify that the creating a sell order deducts stock from the batch with the earliest expiration date first. So I have randomly select one drug as an example, which is the drug ID G2603. So in the inventory system interface, you can see that the quantity in the first batch has decreased, which corresponds to the batch with the earliest expiration date. And this will confirm that the system deducts stock following the earliest expiry first principle.
In this project, we use Apache Airflow to automate the workflow pipeline instead of running script manually and repeatedly. So Airflow allows us to define workflow in a structured and manageable way. Each workflow is defined in a DAG file, and one DAG can handle multiple tasks. So each time represents a specific job such as data extraction, data processing, and forecasting drug usage. So Airflow will automatically manage the execution order, scheduling, and dependencies between these tasks, ensuring the pipeline run reliably and consistently.
So for our project management, we use Jira for task tracking and follow-up that we have to do and we have done. And we use the Confluence for collecting all project content and the documentation. And here we have visit the hospital to discuss and consult with the pharmacies to identify the real pain points that we can develop a precise solution for their needs. And that's all for our presentation. Thank you so much for your attention.